Alright, so in this video we're going to take the activity that we did in class and try to do this basically for a much larger time, much more quickly. So if you recall for your activity, we had this tub of beads, you had yellow beads, you had black beads. And you took out certain samples, and we kind of recorded how many were yellow, how many were black, and we also focused on the proportion of black. So kind of as an example, your numbers again could probably be different than mine, so remember that. So we kind of did this, the samples of size 10 beads. I did the first two. I actually drew my little graphs to go along with it. We focused on the proportion of black beads, so I had 50% or 0.5 for my first one, 40% for my second one. Did it 3 more times, so my 5 numbers I had were 50%, 40%, 30%, 40%, 40%. Those were my numbers. So we're going to take this idea and show you how a sample distribution works by using StatCrunch. So I'm going to first pull up my StatCrunch. I don't need to load any data set at all. First I want you to watch me do this, keeping in mind all of your numbers will match what I am doing. You can always try this on your own. As we'll note at the end of the video, if you do this again, you will get slightly different numbers, so don't worry about that idea. Just like how every group could have got different numbers in class, if you were to do this again, you're going to get slightly different numbers as well. So following the notes directions, I'm going to app lengths, and I'm going to sampling distributions. I'm going to choose the binary option, and we're going to put in a P of 0.4. So what this number actually represents, and I didn't tell you this of course at the beginning, but inside each of your beads, there was actually 40% black. So 40% of the beads in all of the tubs were black, and the rest, the other 60%, were actually yellow. So I'm kind of setting up my little simulation here to have 40% of my beads being black. And then I'm going to hit compute. And then we're brought up with this idea. Now what we need to actually worry about is we're going to be focused on what's called the proportion of ones. What a 1 would represent here is a black bead, and what a 0 would represent here is actually a yellow bead. So I compare this, it's in the opposite order. So I have black on this side and yellow on that side. Don't let that part confuse us too badly. The first thing it tells us to do is to change the sample size here to 10. So that's going to recreate what we did the first time. Remember, we just pulled out 10 beads. And I'm going to click this one time here at the top. So it's pulling out my 10 beads. And in this sample we found that 6 of the beads pulled out were black, 4 of the beads pulled out was yellow, and we get this proportions of ones. And what that actually is then is our sample proportion that I would have recorded like down here. So we're going to record that. That's our P hat. And our P hat for what we just did turned out to be 0.6. That's what happened for that. So black corresponded to a 1 here. This is a little reminder. Now we're going to hit the reset button. And so I'm going to click 5 times. So it's going to recreate everything I did right here very quickly for me. So I hit the 5 times. It's going to pull out my first sample of 10 beads, get the proportion of ones, put that on the plot down here. Next sample of 10 beads, get my proportions of 1, put it on the plot. And it's going to do that 5 times here for us. So it's done it 5 different times. We had 1 at 0.3, 2 at 0.4, 1 at 0.5, and 1 at 0.6. So what this would be similar to, we have the top of the following page here. Here where I created my little dot plot. That's very similar to what we have in this plot here. It also records some extra information here for us. It gives us the mean, the median, and the standard deviation. And right now I'm just going to label those numbers right here on the notes like it tells me to. And I'll go back to our StatCrunch so you can see where I'm getting that. So the mean that we got is 0.44. The median that we got was 0.4. And our standard deviation that we got was 0.114. So we have those things labeled. Now, instead of just doing this 5 times, I'd like to do this many, many, many times. So I'm going to go ahead and reset what we have, and I'm going to imagine that we're doing this now 1,000 times. So imagine we have a whole bunch of people, they're pulling out 10 beads, they're going to calculate the proportions of ones, we're going to put that number along the bottom, so we're going to do this 5 times thing, basically 200 times. Or something, we're going to be doing that a lot. But the 1,000 times isn't going to show me all the animation, it's just going to do it very quickly. And so now I have this big plot with all my different values on it. I now have a mean and a median and a standard deviation as well. And we're going to record those mean, median, and standard deviation. So if we go and look at those numbers now, the only difference from the numbers I have up here and the numbers I have down here was how many times I did it. So up here we just did this 5 times. Right now we've done it 1,000 times. So which set of numbers do you think you would trust better? Those when you only did something 5 times or when you do it 1,000 times? I hope it makes sense. If we do something 1,000 times, we're very much going to trust these numbers much more. But something we should notice, because we forced a certain number to have happen, right? So when we did this, 40% of all the beads actually were black. So what that should mean is that if I pull out 10 beads, I should expect about 40% of them to be black, right? If 40% of all of the beads are black, 40% of the beads in my sample should be black. If I go back and look at my plot, right, this tells me the proportion I got. So sometimes I actually got no black beads. I actually got all yellow beads here. Didn't happen very often though. Notice that bar is not very high. I got 10% black beads sometimes, 20% black beads sometimes, 30%, 40% the most often, which sort of makes sense because it is 40% black beads. Got 50% quite often, 60% not quite as often, 70% sometimes, 80%, a couple, but I never got 90% or 100%. I could, right, if I pulled out 10 beads, I could get 9 out of 10 to be black. I could get 10 out of 10 to be black. But it's not very likely to happen when only 40% of those beads are black. So I shouldn't be too surprised that it piles up around this 40%, because that's really the percent that were black to begin with. Right? So we did this in class as well. I changed things up on you and then asked you to do 20 beads instead of just 10 beads. Now I'm going to jump straight to doing it 1,000 times for our simulation, but just remember what we did in class. So you pulled out 20 beads, I counted how many were black, how many were yellow, I made my little graph to go along with it. I did it again. So we're doing the exact same thing, we're just pulling out more beads each time, which of course is actually even then more work, which is where the simulation becomes very nice to be able to do. So I'm going to change my sample size to be 20. But I'm going to actually just kind of real quickly just show you the one time just so you see what's going on. Alright, so it pulls out 20 beads, figures out what percent were black, and plots it. Now we're just going to do the same thing and jump to doing it 1,000 times. And we have a new looking plot. I mean, it kind of makes sense that we have different numbers here on it because different numbers are possible, right? Before, there was no way you could get 45% black when you only pull out 10 beads. So my numbers are a little bit different here. But I'm also given a mean, a median, and a standard deviation. And I'm going to label those numbers. So I have those numbers labeled now. So let's actually start by comparing what happened when we got 20 beads compared to when we had just the 10 beads. So we're going to kind of compare these two sets of numbers. So what do you notice is similar about them? What do you notice is different about them? Well, they do actually have exactly the same median, so you kind of feel that. The mean, a little bit different, but still pretty close to that 40%. Standard deviation is a little bit different. Do you think these really are different numbers? How does the standard deviation changing really affect things? Remember, we talked about standard deviation when we talked about the normal curve. And standard deviation did have an effect on things. So let's think about what that meant here. Alright, so in our last graph, we went from 0% to 80%. We're not quite going out as far. Notice we're only going out to about 10% to just barely 75%. So my data is not quite as far spread out. So that's what we notice here so far. So now if you had to think about what do you think will happen, we didn't do 50 beads in class, but then instead I go through the same idea. I'm going to pull out 50 beads every single time, go through the simulation again. How do you think that's going to affect the mean, the median, standard deviation compared to what we have here? Is it going to impact the mean? If so, how do you think it will impact the mean? Will it impact the median, do you think? And if so, how? Will it impact the standard deviation? And if so, how? So this is something I want you to think about. I'm not going to write down an answer here. So I want to see if this is intuitive or not. So then we're going to actually do it. We're going to see what does actually happen. But if you need to pause the video here to actually think about it. Don't just jump to see what actually happens. Let's actually think about what will affect having a sample of 50 do. So all I'm going to do is change this to 50. Quickly again, because I'm just kind of showing you what happens with one time. So one time we pulled out our 50 beads. It appears at about, let's see, 22 of the times it was yellow, and 28 of the times it was black. So I have 56% of them were black. Plotted my little 56% down here. So I only have one number so far. Alright, we could do that 5 times. Got 5 different little proportions along here. Now let's go ahead and jump. Let's go ahead and do it 1,000 times. Alright, so here's our mean, our median, and our standard deviation. So first, from a visual standpoint, you kind of notice the data got a lot closer together. Right, so now we're only going from about 18% to maybe, let's say, about 56%. Right, so it's a much more squished in. Never did we get no black beads. We nowhere near got 100% black beads. Right, so we're getting much more closer together. What's that showing up for us? It's in that standard deviation. So I look at how these numbers compare to what we had before. Notice the mean and medians are about the same. So the standard deviation went from 15% to 11% to now about 7%. So the standard deviation did get smaller, but the mean and median did not really change. So what did happen? Our mean and median were not really affected. And that's what we saw that for each time. So whether I sampled 10 beads or 20 beads or 50 beads, the mean and median were not really affected. However, our standard deviation got smaller with more beads. also, because this is going to help you kind of dive into class a little bit better next time, look at this picture. You notice how it kind of looks symmetric and bell-shaped? It kind of looks like a normal curve that we've seen before. So we're going to try to take this idea of a normal curve and be able to apply it to things next time. But again, what I want you to remember is when we sampled, go back over here, each time I did this of these numbers, and I'll go ahead and box those in, that way all the box numbers are the ones that we're comparing. Or I did 20 beads, or I did 10 beads. That's each time I did 1,000 times, and that doesn't really impact anything. I did 1,000 times. What was different each time was sampling 10 beads, 20 beads, and then finally doing 50 beads. Okay, so all I'm doing is taking out a bigger sample from that container and seeing how that affects things. Notice that I'm pretty accurate, right? We know 40% of the beads are black, and we're getting that mean and median right around that 40%, regardless if I only sampled 10 beads or 20 beads or even 50 beads. But we're getting a very different standard deviation. What does that different standard deviation again really mean? So right, we took different samples and you got different numbers each time. How far off from that 40% can we expect to be? That's this idea of that standard deviation. If I'm pulling out 50 beads and you tell me that you got no black beads, I might think that you were doing something a little weird, because that never happened here, right? Never. So I kind of know how far off I can expect to be from that 40%. That's the idea what that standard deviation actually is. If you want to, you can play with this yourself now. Again, you'll get slightly different numbers, because notice like if I reset here and do 1,000 times, I don't get exactly the same mean, median, and standard deviation that I had before. So you can get slightly different numbers. If you want to play with that idea, right, you can even go all the way back and you can change this proportion of black. Right, so we start with 40%. So I mean, you can change that number, kind of see how that affects things as well. But we're going to talk about getting this idea, this activity, and what is that actually going to mean for what we're going to do in statistics.